Hi everybody, I hope this video finds you well. In today's video, we're going to continue on with our next major topic, which is conditional analysis. In the previous video, we spent some time introducing conditional analysis, what the goal was, which was to understand the relationship between two categorical variables. And we talked about a couple major aspects of this analysis. We discussed in the previous video the main organizational technique for understanding data that's been categorized according to two categorical variables. That was what we called the two-way table. We also talked about a way of viewing the two-way table instead of in terms of actual frequencies, in terms of relative frequencies, which is what we call the marginal distribution. And then the sort of technique that we introduced to actually achieve this goal of understanding the relationship between categorical variables was the idea of what we called the conditional distribution. Remember, the conditional distribution depends on choosing one of the two variables as the explanatory or the independent, and then calculating the relative frequencies inside each of the categories of that explanatory variable. So to put all that into context and actually to see how that sort of helps us understand data that we might get in a study or an experiment, let's go ahead and take a look at an example of this. So, for this example, we're going to suppose that you work for a drug or pharmaceutical company that is working on a new pain reliever called Cheapo Comfort. You conduct an experiment where a large group of participants who are suffering from chronic pain symptoms are randomly assigned to take either Cheapo Comfort, which is your drug, standard aspirin, or a placebo. They are then asked after a few hours if their pain has been removed, which is, of course, the best possible result of the medicine, if their pain has been reduced, which is definitely a positive outcome, though perhaps not as good as being removed, or if their pain did not change, which, of course, is a negative outcome, basically meaning that the treatment they were taking didn't do anything. So we get the following data. In other words, we get this two-way table. Notice here are the three treatments, either taking Cheapo Comfort, aspirin, or the placebo. And here's the sort of effect or the result. Either the pain was removed, the pain was reduced, or the pain did not change. So we're going to answer a bunch of different questions about this. We're going to try to figure out what was the sample size. Notice it's not mentioned in the paragraph, so we'll have to get it from the data here. We're going to calculate a couple percentages. What percentage of the sample received Cheapo Comfort? What percentage of the sample received the placebo and said their pain was removed? Then we'll get into constructing the conditional distribution based on the type of drug received. And then in parts E and F, we'll actually use the conditional distribution to decide if there's evidence that Cheapo Comfort works and whether or not there's evidence that Cheapo Comfort works better than aspirin. So let's go ahead and get started with this. As we discussed in the previous video, the first thing we always want to do when we see a two-way table is fill in, if they're not there already, the totals. So let's go ahead and get the row totals. We'll add those up. So we'll do 11 plus 38 plus 17. And it looks like the first one we should get is 66. Then 17 plus 19 plus 18. 54, and then 5 plus 12 plus 26, 43. And then the column totals, 11 plus 17 plus 5, that's 33. 38 plus 19 plus 12, that's 69 there. And 17 plus 18 plus 26, we should get 61. Then we can get the table total. We can check if we add these up, 66 plus 54 plus 43, we get 163. You can confirm that if you add up this way, 33 plus 69 plus 61, you of course also get 163. The sum of these has to be the same as these because the table total has to be a constant value. All right, so we haven't even started trying to answer the questions. We just wanted to get those totals on there because they're going to be useful to us. They're good summary things to have, and they're going to help us answer some of these questions. So for part A, we want to know what is the sample size. Well, we know that the table total is the same there. So the sample size here was n equals 163. So apparently we had 163 people participate in this this experiment, taking either Cheapo Comfort, aspirin, or placebo. So our sample size, 163 right there. All right, let's go ahead and see here. Next one, we want to know what percentage of the sample received Cheapo Comfort. Well, first thing we want to just make sure of here is notice it says what percentage of the sample. So we know that we're saying out of the total sample. So we're going to be dividing by 163. We want to know received Cheapo Comfort. We can see that right there. So we can do this as 66. There were 66 people who received Cheapo Comfort as their treatment. divided by the percentage of the sample, so 163, because there were 163 people in our sample. If we go ahead and do that, 166 divided by 163, we should get as a decimal that this is 0.405, which means that 40.5% of the sample received cheapo comfort. So about 40.5% of the people who came in for this experiment received the cheapo comfort treatment. Okay, let's go ahead and take a look at another one then here. We also want what percentage of the sample. So once again, we know we're going to be dividing by the sample size, which is at 163. Received the placebo and said that their pain was removed. Now, and, of course, mathematically means that they have to have both of these traits. So in other words, they need to have received the placebo and they need to say that their pain was removed. So the fact that they have to have both of these, placebo and that the pain was removed, well, we know all the placebo people were here and all the people who had their pain removed were here. That intersection right there would be that 5. So only 5 people received the placebo and said their pain was removed. So that's going to be our numerator there. So this is going to be done as 5 and then divided by that 163. And again, if we get that as sort of a decimal to start off with, 5 divided by 163, we should find that as 0.031. And converting that into a percentage, we can say that 3.1% of the sample received placebo and said pain was removed. So the key thing to just think about here in terms of terminology, these two things that we did right here were both relative frequencies. We were dividing in both of them by 163 because it's the percentage of the sample. The key sort of thing in C also was that and sort of indicates the intersection. It was the intersection of all the people who took the placebo with all the people who had their pain removed. So it had to be just those 5 individuals that had both of those traits. All right, let's go ahead and look at part D. So for part D, we want to do the conditional distribution, and notice it says based on type of drug. Okay, so remember that when we want to build the conditional distribution, we're either going to divide by the row or column totals because we're going category by whatever is being chosen as the explanatory. Notice that it says based on type of drug. Well, we can see that the treatment types were in the rows, cheapo, comfort, aspirin, or placebo. So we're going to divide by the row totals. In other words, we're going to do our analysis row by row because each row represents a different treatment. So we're going to divide by row totals. In this problem, what would cause us to divide by the column totals? Well, if it said construct the conditional distribution based on the effect, right? Whether or not it was removed, reduced, or did not change, then we'd go column by column and use the column totals. Of course, that wouldn't make a lot of sense because it doesn't make sense to use the effect as the explanatory, right? The treatment should be the explanatory here. So we're going to divide by the row totals. So let's go ahead and do that. You know what? We'll go ahead and do that on the next page. I think we already have the data there. Yeah, we'll go ahead and do it on the next page. I'll just fill back in real quick those totals that we had, just so that we have a little bit more room. So if we remember, these were our totals here. And 43, and then for the column totals, just so we have all that. And 61, and then our overall total was that 163. Okay, so that's the data that we had there, and for this part D, we said we were going to go ahead and divide by the row totals. So we'll do a little bit of abbreviation. CC will be cheapo, comfort, aspirin, and placebo, and then we'll have remove, reduce, and we'll just say DNC, I guess, did not change. Okay, so we'll go ahead and rebuild our table. All right, so remember, we're going to be dividing by the row totals. So for 11, we'll divide by that 66. So 11 divided by 66. we should get 16.7%. Then 38 divided by 66, we'll get 57.6%. And then 17 divided by 66 looks like we should get 25.8%. So remember that these three should add up to 100% because this is basically what happened exclusively to the people who took Cheapo Comfort. About 16.7% of people who received Cheapo Comfort said that their pain was removed, 57.6% that took Cheapo Comfort said it was reduced, and 25.8% said basically nothing happened, their pain did not change. All right, let's do the same for aspirin. Now we're going to be dividing by 54, so 17 divided by 54. We should get 31.5%. 19 divided by 54, 35.2%. And then 18 divided by 54 looks like 33.3%. Finally, for the last row, we'll be dividing by 43, which is the amount of people who took the placebo. So 5 divided by 43, we'll see that's 11.6%. 12 divided by 43, that's 27.9%. And 26 divided by 43, that is 60.5%. So there we go. There is our conditional distribution based on the type of treatment they received. All right, let's see if we can use this to do a little bit of analysis. Part E, if we go back and we take a quick look. Sorry, there we go. All right, if we take a quick look, we said that for Part E, we want to say, using the conditional distribution, is there evidence that Cheapo Comfort works? So how are we going to do that? Well, we want to make sure to use the conditional distribution, and we want to know, does Cheapo Comfort work? Well, if it works, well, Cheapo Comfort should do a better job than the placebo. Because remember, what is the placebo? It's a fake treatment. So if you want to make sure that your drug really works, it needs to do better than the placebo. If it's the same as the placebo, then that just means the only reason it's working is because people think they're receiving a treatment. It needs to do better than the placebo. So let's go ahead and see if that's the case. So we're going to be doing Cheapo Comfort versus the placebo. Well, if we look here, notice that the percentage of people who had their pain removed by Cheapo Comfort was 16.7 versus only 11.6 for the placebo, so that's a good sign. For reduce, it's even better, 57.6 versus only 27.9. And for do not change, it's 25.8 versus 60.5, which is also a good thing because obviously this is the sort of negative outcome, and there's a lower rate for Cheapo Comfort than there was for the placebo. So we can basically say Cheapo Comfort had better rates of remove/reduce compared to placebo and a lower rate of did not change. So Cheapo Comfort seems to work. Right. In other words, this information here, at least as far as our analysis would show, is encouraging, right? Cheapo Comfort did better at removing pain than the placebo. It did way better in terms of reducing pain than the placebo, and it did better in not doing anything compared to the placebo because this rate was lower. So for the two positive outcomes, Cheapo Comfort had higher rates, and for the one negative outcome, it had a lower rate. So it does seem to work. All right, now let's go ahead and look at part F. So now that we're convinced that it works, does that automatically mean that it's like a marketable drug? Well, we want to say, using the conditional distribution, is there evidence that Cheapo Comfort works better than aspirin? So now we're going to be comparing Cheapo Comfort against aspirin. So let's go ahead and do that. So we're doing CC versus aspirin. All right, now you might notice that this is a little bit more complicated of an issue here. If we look at the remove outcome, which again is the best, Cheapo Comfort only did that 16.7% of the time, whereas aspirin was 31.5%. That's not a good sign if you're somebody who is invested in Cheapo Comfort, because aspirin has a higher rate of removing the pain entirely, which is the most positive outcome, than our new drug. But not everything is bad here. If we look in this category, right, the reducing, which again is a positive outcome, Cheapo Comfort did that 57.6% of the time, whereas aspirin only did that 35.2%. Now, of course, somebody who maybe makes aspirin or somebody who's critical of your drug could say, well, this percentage is higher because this one is lower. So there's a little bit better of an argument for cheapo comfort. If you think about it, really one of the best arguments for cheapo comfort over aspirin is that there did not change the pain, was 25.8%, which is a good bit lower than aspirin, which is at 33.3%. So the sort of point here is that you could sort of argue this both ways, depending on what you sort of want to focus on. If you were pro cheapo comfort, we could argue, so pro CC, what we could say is CC had lower rate of did not change or did nothing than aspirin. You could also say, in another way, which is basically the same as what we just said there, CC had the higher combined rate of reduce than aspirin. What do I mean by combined rate? Well, imagine adding these together. If we add the remove and the reduce, for CC it would be 16.7 plus 57.6. It means that about 74.3% of people had some positive effect after taking cheapo comfort. Whereas aspirin, if we add these together, 31.5 plus 35.2, that's only 66.7. Now, of course, that's the same as just looking at these and doing these minus 100%, but either way. The point is that if we were to sort of positively argue for the cheapo comfort drug, we would say that it basically seems to at least do something for a larger percentage of people. If we were anti cheapo comfort for whatever reason, maybe we were critical or maybe we work for a different company or whatever, well, our main thing would be that CC had lower rate of remove than aspirin, which is the best possible outcome. So the big criticism, right, of cheapo comfort from our data would be that it had a lower rate of the best possible outcome, but it did seem to do at least something to a wider range of people. So this is to sort of demonstrate to you guys that whenever you're interpreting data, sometimes there can be several interpretations here, and just wanted you guys to sort of see a sort of pro way or sort of a positive way of interpreting the results, as well as a negative way in terms of the success of this drug. Now, notice that either way we look at it, there is no reason to believe that our cheapo comfort does not at least work. We were very convinced across the board that cheapo comfort was better in terms of the placebo at removing, better in terms of versus the placebo in terms of reducing, and better at not doing anything, lower rate of not doing anything than the placebo. So we're definitely convinced it works. Whether or not it is better than another drug, that is more up for interpretation. So this was a chance to see how conditional analysis can be applied to sort of an experimental setting and looking at something where we have different treatments and trying to analyze whether or not some of those treatments were more effective. In our next video, we'll take a look at another example of performing this conditional analysis with a sort of another data set more focused on the relationship rather than looking at it from an experimental sense.